So we shall continue. Yesterday I've started with the new chapter, that is general principles and process of isolation of elements, called as metallurgy, and you have seen. So just we'll have a brief, okay, go like we'll go through whatever is been done in the yesterday's class. Brief revision of what is done. So yesterday we started with metallurgy, and I told you metallurgy is a process of extraction of metal from the ore and its utilization. That will be called as metallurgy. The whole process, no, where you are trying to get the metal from the ore and utilize it for our purpose, that comes under metallurgy. Okay, and then uses, I have mentioned uses, you have so many. And then next, a few terms also you have learned, no, related to this metallurgy, that is minerals. Minerals are naturally occurring chemical substance which you get from the earth crust. As whatever you are getting from the earth crust, I told you that can be called as minerals. But there is a difference between minerals and the ore. Okay, ores are those minerals from which metals can be extracted. Okay, metals can be how? It should be convenient and it should be economical. Okay, so if it is convenient and it is economical, that means a person is able to make profit out of that, then that can be called as ore. So you can't call all the minerals as ore, but all the ores can be called as minerals. Okay, because all the ores are minerals, because that will be extracted from the earth crust. But all the minerals are not ores, because from all the minerals you may not be able to get profit. Okay, everything may not be economical, so we can't call all the minerals as ore, but we can call all the ores as minerals. Okay, so this statement you should know why it is called like that, and you should be able to give the reason as well. So that was about the ores and minerals, and then we have seen what is gangue. Okay, so this gangue are the contaminant particles. Okay, these are impurities which will be associated with your ore. So if you all have those earthy impurities, like for example, you see here sand is there, soil is there, clay will be there. Okay, and so many other things. Sometimes these organic materials also will be present along with this. So those things which are associated with our ore, they are categorized as gangue. Okay, and then next is flux. Flux, I told you, they are the substance which are used to remove the gangue particle. Okay, they are used to remove the gangue in the form of slag. Okay, so that will be in the fusible mass form, a liquid form. So that will be thrown out from that. Okay, it will be removed out. So most of the time when we do the extraction of iron, they add limestone is added. You know, limestone is calcium carbonate. So when limestone is added, that calcium oxide formed during that heating combines with the sand, that is silicon dioxide, or I can even call them as silicates. They combine together and they form calcium silicate. Okay, so they give rise to calcium silicate, which is the slag. Okay, and that I had shown you also. This is at very high temperature, but at the end, if you see, it will be almost like how you have your no stones are there, no, it will look like that only. How the pebbles are there, it has a similar features related to that. So slag is just a fusible mass. It's a fusible mass formed by the gangue and the flux. Okay, and then we even discussed the most abundant, you know now, which is the most abundant element in the earth crust, that is oxygen. Okay, and then silicon is the second most abundant element. First is oxygen, followed by silicon. Metal also you should know, because we are talking about here metallurgy, extraction of metal. The first most abundant element in the earth crust is aluminium. Second most one is iron. So aluminium is cheaper because of that abundance only. This is a pie chart, and then after that we started with concentration of the ore. So what was that concentration part? Concentration is where you are trying to remove the unwanted impurities from the ore. Okay, so they will be associated with them, no, so you have to clean it out. It is just a cleaning process. In a simple word, if I have to tell you, it is just cleaning. Okay, like I gave you an example. When you get the vegetable at home, first thing what we do is we have to clean the dust particle, the clay particles, and the sand which is associated with that. Okay, then you will start, no, then you will go for chopping it, and then you will go for cooking them out. So first thing what we have to do is cleaning. Okay, so even when the ores are brought out, There will be so many things associated with that. So cleaning that comes under concentration of ore. There are different methods, like we have hydraulic washing, then we have magnetic separation, froth flotation, and leaching. These three we have discussed yesterday: hydraulic, magnetic separation, and froth flotation. In hydraulic washing, I have told you that you are just passing the powdered ore, and then the water is continuously passed over it. So when you pass water continuously over it, the light and the no the clay particles which are present, the dust particles, that will that will be washed away, and the heavier ore particles will settle down. So it is basically based on gravity. Based on the gravity, the heavier particle settles down, and the low weight particles will be thrown away. Okay, so this is one more animated picture I had shown you, that from this side we are passing the ore, and then you can see there is no water, continuous water is being passed from the another end, and then they are just rotated. So cleaning will be done there. Okay, next we are having magnetic separation. Magnetic separation is possible for those ore which shows no they show attraction towards a magnet. So if there is difference in the magnetic property between the ore and the gangue, then we can go with this method. Okay, with difference in their magnetic property means both of them, I had told you, both of them should not get attracted, and both of them should, like, if both of them are getting attracted, then it's a problem. No, you can't get the separation, because everything will come together. So both also should not get attracted by the magnetic field, neither both of them should not get attracted with the magnetic field. Okay, either one of them should show attraction towards the magnet. So if there is a difference between that ore and the gangue, then you can have this separation technique. So when you put this powdered ore from this side, you can see from this end, they have powdered the ore and they started putting on this belt. Okay, so when you put them on the belt, the magnetic roller has a conveyor belt over here, which will be continuously passed. Okay, so when this powdered ore is being passed, the magnetic roller, which has a magnet, will attract the ore towards them, and these unwanted impurities will be thrown away. Non-magnetic material will be thrown away. Okay, so that's how the separation has been done. One more animated picture over here to give you a clear idea. You can see these black dots which are there, those are the iron particles. These are iron particles which are coming near the roller, and the one which are red in color, those are the unwanted gangue particles which are being thrown away. Okay, so they will just go away because they are not getting attracted. So easy to separate like this. And then the next method is the froth flotation we had discussed, and for which ore also it is done, I had told you. Usually for concentration of sulfide ores, we carry out froth flotation. So sulfide ores are separated using this, like zinc sulfide, you can take copper sulfide. Okay, you can apply this method. So in this method, from one end, you can see a long agitator over here. So that will contain the air molecules coming from that side. You can see here there are holes also, okay, which helps you to pass the air. And when you completely agitate that mixture, froth will be formed. Like when we want to get the froth, no, in the from using the detergent also, continuously we will try to put like we will put our hand and try to agitate that mixture, no. So similarly here, this long tube is being used, and continuous agitation creates the froth. But then here you are creating the froth of the sulfide ore. Sulfide ores are not very good. No, they are not very good, I can say, colloidal particles. So for that you need something to collect them. So we are using a collector here. Pine oil is taken, pine oil, and or you can use fatty acids, or you can use xanthates. These are called as collectors. Since they are unstable, we need a stabilizer also. Okay, so we need a stabilizer like aniline and cresols are added here as a stabilizer. Okay, this I told you, it is similar to how we extract butter from buttermilk. And this was the representation, like in industry, how that sulfide froth looks like. And one more thing which I had discussed over here is, like, when two sulfide ores are present, like if you are having zinc sulfide and lead sulfide, then to separate in that case, we need to add something along with this. What is that? I had told you, it is called as depressant. Okay, so we add depressant so that one of the sulfide will be suppressed there and only the another one will be taken. Okay, so when we add NaCN as a depressant, example for depressant is NaCN. You have to remember this. This was asked also. Okay, this was asked. What is the depressant which is added? So in this case, NaCN is added. When NaCN is added, it will combine with the zinc sulfide and they form a complex. So it will suppress them and allow only the lead sulfide to come in the form of froth, and that will be skimmed off. And then this can be later broken down and separated. Okay, so that I have put over here. The role of stabilizer here, stabilizer's function is to stabilize the froth. Because it is sulfide sol which is not very stable, doesn't form, they are lyophobic in nature, so you need a stabilizer. And depressant function is to prevent the particles from forming the froth. So example over here was NaCN which we have taken. Okay, next process, very important students. Okay, this is for 3 marks. If this question, usually they ask this question, okay, from the general isolation, if any question is asked, one among that will be this question for 3 marks, okay. So make a note of that. That is leaching process. Leaching is a chemical method. It's a chemical method. So far, whatever you saw, okay, they come under physical method, because there is no chemical reaction as such happening. Okay, you are just doing physical reactions, and physical methods, they are just separating them. Okay, no chemical reaction as such. Now in this leaching method, it's a chemical process which is being carried out. Okay, it's a chemical method which is carried out. Now how is it happening? So here the chemical substance is chosen in such a way that the ore which is there, okay, the ore is soluble. The ore which is you are going to separate, that ore is soluble in that, and the impurities are there, no, that is insoluble. Okay, so you have to choose that chemical in such a way that your ore what you are taking, that should be soluble in that, it should be forming a soluble compound, and your impurities are there, no, the impurities which are present in this ore, that should be insoluble. Just understand here, that's how the choosing of that chemical substance has to be done. Okay, so it may not be applicable for everything. You have to find out which ore is soluble in that particular chemical compound. So one suitable reagent which is matching with that has to be taken. Okay, so I hope this is understood. The ore which you are taking should be soluble. Okay, that should be forming a soluble compound, and the impurities which is present, that should be insoluble. Okay, that process comes under leaching process. Now here this method comes under leaching process. So then you can recover that ore from that. So 2 leaching process you are going to study. One is for alumina from bauxite ore. Okay, first one is for leaching of alumina from the bauxite ore. Second one is leaching of gold and silver. So we'll start with the first one, leaching of alumina from bauxite ore. This ore picture which I have put over here, that's bauxite ore. Bauxite is one of the most abundant ore of aluminium. Okay, so that is bauxite ore, which is alumina. Alumina formula is this, Al2O3. Okay, now see how this reaction has been done. So alumina has to be dissolved in that compound in which they are soluble. They are able to form a soluble compound. So what they do is they carry out this reaction at very high temperature and pressure. Okay, this reaction is carried out. I'll give you a brief idea. First, I'll tell you what is happening. Then we will go with the equation. Okay, this reactions will be almost similar to like how you had no, the sulfuric acid preparation and all that, because it is inorganic. No, so step by step you will have to write it, and you will be having to write a balanced equation. So each equation will give you 1 mark. That full writing the balanced equation will give you 1 mark. So this is being carried out in 3 steps. So let me explain about that. So here to dissolve your ore, what they are taking is sodium hydroxide is being taken. Okay, first let me explain you in brief. Sodium hydroxide is being taken. This sodium hydroxide is mixed with alumina. Okay, it is mixed with alumina, which gives you a soluble complex. It gives you a soluble complex in water. This will be soluble. Okay, it will be soluble in your aqueous solution. Plus whatever impurities are present, no, that impurities is not soluble with sodium hydroxide. Okay, they don't form any complex with sodium hydroxide, and they will be insoluble. So they stay there in the solution. Okay, so they will be insoluble. Whatever impurity is being present in this, most of the time the impurity is present in this bauxite ore. You can see it is red in color. That's because of iron oxide present. Fe2O3 is present and silicon dioxides are present. These are the impurities. Okay, these impurities will stay there as it is as a precipitate, or they will settle down as this dust and the clay particles as a suspension, how they settle down. No? So they will be there in the bottom. Only this solution will be there, which will be clear solution. So all of your alumina will combine with the sodium and form a clear solution. So then you have to filter it out. Okay, you need to filter it out. Filter them. When you filter it, all these impurities will go away, no? So then whatever you have in your hand will be that complex, okay, that sodium and aluminium complex. So that complex, to that complex which is being formed here, to that complex what we do is we pass carbon dioxide gas. Carbon dioxide gas is being passed, okay. So it is in the gas form, so I have just written G over here. So complex combines with the carbon dioxide and they form a insoluble compound. They form a insoluble compound plus one more soluble impurity will be there. Okay, now it is in insoluble form. Insoluble aluminium complex will be formed. That insoluble complex which is formed, again you have to filter it out. Again filter them out. So once you filter it out, it will be like in the form of a precipitate. No, that precipitate which is there, I'm just writing PPT, that should be heated at very high temperature. Finally, you will get back your alumina. Okay, how it is happening with equation, I'll explain that to you. But at least you got a brief idea what has to be done. These are the three steps which are being followed, okay, to extract the pure alumina from the bauxite ore. I'll repeat it once again. Leaching process is that process in, it is a chemical method. It's a chemical process. Okay, this process is a chemical process where you have to take that chemical reagent in which your ore is soluble. Okay, in which your ore will be soluble and your impurities are present. No, that impurities which are present should be insoluble in that. It should not form a soluble complex. So whichever impurities are there, that can be thrown away easily. Okay, it can be filtered away easily. So I said the impurities present in bauxite ore, usually it is either iron oxide or silicates. So that will stay there only and you will be getting a soluble complex. That soluble complex has been filtered out and that filtrate is allowed to pass through carbon dioxide and precipitate them out, because again you should get that in the solid form. So you need to precipitate them out with certain method. So here carbon dioxide is being passed to form that insoluble precipitate, and then again some impurities still will be there, that will be soluble. So now you get that precipitate, heat them at very high temperature, you will get your compound back. So this is how the purification is being done. Okay, the concentration, I can say the concentration has been done. Now let's go for the equation. Did you get a brief idea what has to be done? Then you will have to study the equations. So let's continue with that. Okay, let's start with that equation. Okay, the equation which you need to study. So the element which is taken here, I said it is sodium hydroxide. So let's start with the first step. In the first step, you are supposed to take your alumina. Alumina is the bauxite ore. That's alumina. Okay, Al2O3, which is in the solid state. You have seen that ore. I had shown you just now. This is your alumina. Okay, which is in the solid state. They are in the powdered form now. This powdered form of bauxite is made to react with sodium hydroxide solution. So NaOH with water. It is a solution of sodium hydroxide. Not only the pellets are taken, you are taking them in the solution form because you are supposed to heat it at very high temperature. This whole solution is heated at very high temperature. Temperature and pressure also you should remember. See, what is the temperature and pressure they are taking? Hope the screen is visible, students. Yes, no, it is proper, right? Yes. Now see the temperature and the pressure which I was telling you. The temperature taken over here is around 473 to 523 Kelvin is the temperature. Okay, and the pressure maintained is around 35 to 36 bar pressure. So when you maintain these conditions, it is found to give you a soluble compound. So that soluble compound, the complex is formed actually. The complex formed is sodium aluminate complex. That is NaAlOH 4 times. Okay. And this is soluble in the solution. So I am writing here aqueous. Rest whatever is there, no? That is your iron oxide and the silicates that will stay down. Okay. Only this will be soluble in your water. So now you can balance it. You can see here 2 aluminum is there on the reactant side. So you multiply on this side with 2. So when you multiply with 2, you get 2 sodium. So this has to be multiplied by 2. Okay. Now count the amount of hydrogen which are there. So if you see hydrogen here, it is 4. And here it is 2. So you have to multiply this by, count the total. Yeah, it is 4 into 2, 8, no? So only 2 are there. So it has to be multiplied by 3. This is the balanced equation. Okay, the first step. Is the first step clear to you? Now we'll go for the second one. Okay, second one, you take this compound now. What did I tell you? What you are supposed to do? For the second step, you will take that sodium aluminate complex NaAlOH4, which is in the aqueous solution now. Okay, which is in the aqueous solution with the water, which is a soluble complex. After filtration is over, now they are in the form of a solution. It's a clear solution now. To this you are passing carbon dioxide. So when you pass carbon dioxide, it will precipitate out in the form of aluminium. See here, Al2O3 with the, it will form hydrate. Okay, hydrate of aluminium oxide will be formed. So Al2O3 with the X molecule of water. Plus along with that, this sodium is there, no? The sodium compound will combine with the carbon dioxide. It is in the solution now. So sodium, water is there and then carbonate is there, like carbon dioxide is there. So it forms sodium hydrogen carbonate. It gives you sodium hydrogen carbonate, which is an insoluble compound. Okay, it is insoluble in this particular thing. So this will be in the solid state. Sorry, this is insoluble. I'm sorry about that. This is insoluble. And this will be in the soluble form. So this soluble form, again, you have to filter it out. So when you filter this out, only this precipitate you will be getting, and this you can throw it. Means it can be used for some other, other compound preparation. You can use it, but now right now for us it's a waste. Okay, now in this reaction I'm talking about. So then after that, the precipitate which is obtained, this insoluble PPT which is being obtained here, that is further taken Al2O3, okay, which is having X molecule of water, is heated at very high temperature, maybe around 1470 Kelvin. It is being heated so that they lose that water molecule and give you the pure alumina. Al2O3 in the solid state plus X molecule of water is obtained again. Okay, since you are heating them, this will escape out and you will be left only with the solid. So you will get that back, but it will be without the impurities. Okay, you will not have anything present in this. So now you make a note of this. And it's a balanced equation here. The last one is balanced. Second one, you will have to balance it. To balance second one, you can see aluminium on your product side, that is insoluble complex, it's 2. You can multiply here by 2. If here it is 2, even this sodium also should become 2. Okay, yes, write it down now. Yes. Yeah, but you need not remember that number because this balancing won't be difficult for you. You can balance it easily. So I am not giving you any clue to remember. Otherwise, there I had told you, you remember the numbers. Like in case of nitric acid, I told you, remember 45 and 46. Here, I'm not giving any number for you to remember because it's easy to balance. Okay, equation you will have to study. So, 3 equations, if you are writing it correctly, for leaching process, you will be given 3 marks. If you finish writing, just let me know. I'll proceed with the next. Yes, students, did you finish? Yes, no, okay. Yeah, we will proceed now with the next one. Next is leaching of gold and silver. Yeah, so I'll continue. I'll go with the majority ones who are replying. If you can, yeah. See here, I have not given the sentence. If you want to explain with the sentence, you can do it. Okay. So that will actually give a better impression. So I'll send that. Anyways, I'm sending that note. So you refer the notes. It is the same thing, but that thing is you are just putting them in words. Same thing you put in words. That's it. Enough. Okay. Don't worry much about that. But equations you all write correctly and balance it properly. So very important is that. So I did not focus much on writing the sentence. So that I'll send it to you. You can write it down. Okay. Yeah. Now next one, we'll move on with leaching of gold and silver. It's a common method for both. So we will be writing a general equation for both gold and silver. Okay. So you know that gold and silver, they are quite like stable elements. No, they are noble elements. You know that. So these are noble elements, noble metals they are. So if they are noble metals, they are not like present in the combined form. Like usually they are in their native forms only. Okay, and extraction of this because they don't react that easily. So extraction method is little different than compared to other. Okay, so that extraction method you are going to learn here. See how it has been extracted. So metallurgy of gold and silver, it's a common method. So I'll be just writing metal M here. Okay, I'll be representing gold and silver, both gold as well as silver with just M, metal. Okay, see how it has been done. This metal, that is gold and silver, is treated with a dilute solution of either sodium cyanide or potassium cyanide. Okay, and only ionic equation you are supposed to write here. We are not going to write the whole compound equation, only ionic equation. So this metal first it is treated, or I'll just give you the brief first what has to be done, and then we will go with the equation. See, first what they do is this metal, that is either gold or the silver one, gold or silver, is made to react with solution of cyanide. Okay, so solution of cyanide is taken. So only Cn minus you can write. Solution of cyanide means there is water and cyanide ion both present. Okay, and to this they pass oxygen. Oxygen gas has been passed. Now what oxygen does is it will oxidize your metal. Okay, it will oxidize your metal and make the loss of that. Now oxidation means what? Making the loss of other metals. Okay, so this metal will get oxidized and they will form a complex with this cyanide initially. Okay, so they form a complex of cyanide. first thing which will be formed will be the complex. I'm giving you the gist now. It's not the equation. Okay. So first it will form complex of a cyanide along with another compound also will be there. So this complex of cyanide again will be soluble, like how we had that sodium aluminate being soluble. This also will be soluble. Other impurities will be insoluble. Okay. It's a coordination compound. So you can remember coordination compounds are easily soluble in the water. Okay. So it is giving you a clear solution here. So soluble compound is formed. Filter them out. Again, this will be filtered out. After filtering is over, you will get that solution. Okay. To that solution now, the complex which is there, that complex is made to react with high reactive metal. Okay. It is made to react with high reactive metal. Now, which is that metal here? They are taking high reactive metal. They have taken zinc easily. You know, zinc easily can react. So zinc will form the complex with that remaining compound and your pure metal will recover back. So impurities anyways will go, no, during this filtering part only the impurities will be lost. So you'll get the metal plus zinc complex will be formed. Okay, so in brief, I told you what is happening during the process. So in the leaching process of your noble metals, that is gold and silver, we take that metal and we treat them with solution of cyanide. Okay, so sodium cyanide, potassium cyanide solution you can take and we pass oxygen. In the presence of oxygen, this metal will undergo oxidation. Your metal will undergo oxidation. So when they undergo oxidation, they will be in the positive form. Okay, so they will come in the positive form, metal M plus form. If it is silver, Ag plus, gold means Au plus. So that will combine with your cyanide ion. And cyanide, you know, it's very good ligand, no? So easily it will come and form a complex. So ligand and metal complex takes place. That complex is soluble plus other impurities are there. Along with that, other impurities are present. So soluble complex has to be filtered. That filtrate is further made to react with high reactive metal like zinc. Okay, the complex which is there, that is made to react with high reactive metal zinc. So this zinc will start forming a complex now. It will displace them and the metal will come out. So recovery of the metal will happen here. Okay, so your metal will be in the solid state here and your zinc complex will be again soluble. Again filter them out. So you will get your metal back. Now let's see the equation, how to write the equation. I'll write it over here. This side I'm writing. So starting with the metal first, metal you take which is in the solid state initially. Again grounded metal means the metal pieces we are taking. Metal pieces are made to react with sodium and potassium cyanide solution. So solution means right just a Cn minus. It is a solution of aqueous solution of water. So water you have to take and then I said you pass oxygen gas which will help you to oxidize the metal. So metal will get oxidized and it will form a complex with cyanide. So metal will be in the plus form. Okay, and it will take 2 cyanide surrounding them. So charge on the metal you see will be 1 minus. Why? Because metal M plus will take 2 cyanide. So 1 cyanide will neutralize the charge. One more cyanide is extra, no? So 1 minus charge. Understood? Why 1 minus charge over here? Your metal has got oxidized, M plus. So 1 cyanide will neutralize the charge. So your metal charge will get neutralized here. But it is taking 2 cyanide. So that means 1 cyanide charge over here is extra. So that charge is what we are showing on the complex. Okay, so 1 minus charge. Plus other compounds which are formed here is the hydroxides. Okay, that means the sodium cyanide if you are taking, that sodium will combine with OH over here forming that hydroxide. So OH minus are also present in the solution. Okay, so these are aqueous which is soluble. Now balance it. When you are balancing, you can remember this number because the numbers are little big. So you can remember here it is 4, 8 and 2. 4, 8, 2 it is. If you remember this number, you can balance on the another side. If metal is 4 here, even this has to be 4. Okay, cyanide automatically it is becoming 8. Now remaining is how many hydrogen here? 2 2s are 4 hydrogen. So this will be 4 OH minus. You remember the left hand side, right hand side you can balance by itself. So metal is 4, cyanide is 8, and this is 2. Water is 2, oxygen nothing. Okay, 1. Now after this, you take that filtrate. Your cyanide complex is there, no? So that complex is taken, Cn2 minus, which is in the aqueous solution, is made to react with the reactive metal zinc. So zinc, when it is added to this, it will easily come and displace this metal and form the complex. So Zn Cn4 2 minus is formed. Zinc takes a 4 cyanide ion and forms 2 minus, because zinc valency, you know, it is 2 plus. So 2 plus 4 cyanide is there, so 2 minus has to be the charge. And this metal will recover back. So metal is back now in the solid state. Okay, and this will be in the aqueous solution. So this is how the recovery is done. You can balance it. Cyanide, you see here, it is 4. So that means this has to be 2. If 2 metal here, then this also will become 2. Yes, students, write it down. Okay, here metal, I told you metal is either silver. It is either silver or it is gold. Copy this down. Okay, fine. Very good. So I hope that majority of you have finished. Yeah. So we are done with the concentration process, students. After the concentration is over, you have to extract the metal. Now, yeah, one more thing. Now see, for extraction of gold and silver, it is same thing. Okay, so I won't be repeating it once again. If they ask you what is the extraction method for gold and silver, this is the extraction method as well as it is the concentration method. Okay, it gives you finally the pure metal. So here much of again extraction is not there. It is same thing. Yeah, it is same thing. For extraction of gold and silver, leaching process itself is the extraction method. Okay, so this is for same thing, extraction. If they ask you for extraction of gold or silver, you will write the same equation. So I am not going to repeat once again when I am doing the extraction method. Okay, extraction is a method where you are trying to get pure metal. So now it is in the pure metal form only. Can you see here? It has come back in the metal state. Whereas in the alumina extraction, you see, in the alumina extraction, it is not in the metal form. It is still in their oxide form. So from that oxide, you have to recover the aluminium back. So that means another method has to be implemented. But in the leaching process of your silver and gold, it is not required because you have got them again finally in the metal state only. Metallic state only they have recovered. So there is no extra again process to be implemented. It is done there itself. Okay. Understood why it is not there? I said why leaching itself is the extraction method. But for other metal ores, you will have to do it. So let's see that. Okay. So extraction of crude metal from the concentrated ore. Once the concentration is done, from there you have to recover this metal. For that we are having two major steps to carry out. First thing what you have to do is you have to do the conversion to oxide ore. Okay, if metal is in some other form, then you will have to do the conversion to their oxide ore, because they say oxides are conveniently, like it is more convenient for us to recover easily. Easily the reaction can be done, and even thermodynamically also, when you are going to learn the thermodynamic part also, you will understand that recovering from the oxide state is more easy. It is economical for them instead of going for some other form. Okay, so you have to convert in whatever form they are, try to convert them in their oxide form. Okay, so when oxide form is being bought out easily, then the recovery of the metal will be done, okay, much more conveniently. Then second step after that, if you have got them in the oxide form, then you have to remove that oxygen. No, what do you mean by removing the oxygen? What method is it? Reduction or oxidation? Removing the oxygen. You have to remove that oxygen now. So after that, it is the reduction method, removing the oxygen. Yes, very good, correct. It is reduction. It is reduction of the oxide, finally, reduction of the oxide to the metal. So these two steps you have to carry out. Okay. Convert them into their oxide after the concentration is over. Second step is you have to remove that oxygen and finally get them to the metallic form. Now that is what we are going to discuss, conversion to their oxide and reduction to the oxide to the metal. So there are methods for that. Conversion to the oxide, how it is done, conversion to the oxide. There are two steps for doing the conversion to their oxide. One is calcination. Calcination is the process of heating the ore, but in the absence of air. Okay, it is heating the ore. Calcination is heating of the ore. You are heating the ore, but in the absence of air or very limited supply of air, either absence or very limited supply of air. So if you take that ore, heat them, you will get them in their oxide form. See now, for example, iron ore I am taking, Fe2O3 with X molecule of water. So if these ores are taken, you heat them, it will give you Fe2O3. It is already in that form, but water was present. So if you heat them, this water will escape out. Okay, so we have got them in their oxide form. Then carbonates. Most of the carbonate and oxide ores are carried out with calcination. Zinc carbonate. When you heat zinc carbonate, if air is present, then it is waste. It is vain doing that reaction. If air is present, it will reverse back. Okay, so we have to avoid that. There shouldn't be plenty of air. Little is fine, but then you should see that there is no much air, because otherwise it will reverse back. Okay. So now here carbonate. Carbonate, if you heat, you know what will happen. Carbon dioxide will escape out. So you'll get zinc oxide and carbon dioxide. Similarly, if you have any other carbonate also, same thing happens. Okay, so that is calcination. The next step what you are having is roasting. The next step is roasting. Roasting is just heating, but heating them in the presence of oxygen. So most of the sulfide ores are being roasted. Okay, so roasting is done for sulfide ore. Like for example, zinc sulfide, if I take, zinc sulfide is heated with the oxygen. So then sulfur dioxide will be formed and zinc oxide will be formed. So what you get is zinc oxide along with sulfur dioxide. This sulfur dioxide, you have to remove it out. It can also be used for sulfuric acid preparation. In contact process, you can pass this sulfur dioxide and utilize it. It is not a waste here. Okay, so that is roasting method. Hope this is understood. Students,